Okay, we are back in the second video here on 8.1, our intro to trigonometry. So hopefully you tried these out. Let's see how it goes. The sine of alpha. Okay, alpha is right there. Sine is opposite over the hypotenuse, 5 over 13. And that's that. The sine of beta. Okay, so if we're thinking this angle, we'll still think opposite over hypotenuse. The sine of beta, 12 over 13. All right, how about the cosine of beta? Cosine is adjacent over hypotenuse, 5 over 13. And you notice the sine of alpha is the same as the cosine of beta, just the way that they kind of crisscross, the way you're, opposite, adjacent, right? All right, how about tangent alpha? Tangent, opposite over adjacent, 5 over 12. Tangent beta, opposite over adjacent, 12 over 5. It ends up getting flipped. The secant of alpha. Okay, this is interesting. Secant is the reciprocal of cosine. So if we look at alpha, cosine would be adjacent over hypotenuse. So the secant is hypotenuse over adjacent. In this case, 13 over 12. How about secant beta? Okay. Cosine would be 5 over 13. We did that earlier. So secant is 13 over 5. Cosecant beta. Cosecant is the reciprocal of sine. Beta, sine, would be 12 over 13. So that means the reciprocal, 13 over 12. Finally, cotangent alpha. It's the reciprocal of tangent. Tangent would be opposite over adjacent. It's going to be the other way around for cotangent. In this case, 12 over 5 is your cotangent alpha. Okay, very cool. Just getting used to these trig ratios. We're going to think of them as functions pretty soon when we start doing derivatives and things. But for now, they are what they are. Okay, next up, we're going to look at some more trig values, but this time we're not basing it on a right triangle. We're just going to use our calculator to help us out with these. So actually, I need to grab my calculator. Okay. Sometimes we're going to see degrees. Other times we're going to see radians. So be familiar with how to convert your calculator between each mode. If you're using this one, it tells you up there, it's very tiny, and it's super blurry. That says RAD, radians, and super small words. You can change that by hitting mode on this calculator, switching it to degrees. And now I see degree right there. Any scientific calculator will have both radians and degrees. Typically it's in degrees as the default. So okay, cosine 57 degrees. Here we don't have any work to do. We just got to be familiar with our calculator. Find your cosine button. Mine, and oh, sorry, this is so blurry. Oh my goodness. My cosine button is right there. Cosine 57, if I'm in degree mode, gives me that answer. Round it to 4. Okay, 0.5446 will be that answer. let's try one. How about cosine 1.2? Okay, this is big. They might not come outright and tell you if it's degrees or radians, but you can tell immediately if there's a degree symbol, it's degrees. If there's not a degree symbol, it's radians. And I explained at the beginning, while I switch over to radian mode, radians measures the actual linear distance as you walk around that circle. So it doesn't require, it's like the units are radians, but there's no special symbol like degrees. Okay, so here if I'm in radian mode, cosine of 1.2, there it is, 0.3624, if I round that. So really what is this? Just be careful that you're in the right mode. And okay, I've noted that there, that's radians if they don't say otherwise. One more like that, but now how about a secant? The secant of 0.6. Now this is interesting. I don't know of any calculators that have a secant button. They'll have it's so blurry here. It just can't seem to focus. It's not sure what to focus on. There's my sine button, cosine, tangent. I don't have a button for secant, but I know that secant is the reciprocal of cosine. So here's what I'm going to do. I'm going to do 1 over the cosine of 0.6. That's secant 0.6. I took the reciprocal. So calculator engineers know this. They know they don't actually have to tell me. They don't have to give me a secant button. I'm just going to pull this off the screen. I can't fit it all. The answer here is 1.2116. They know I can always take the reciprocal of cosine to get secant. Same with cosecant. I know I can always take the reciprocal of sine. Same with cotangent. I can take the reciprocal of tangent. Okay, I think I've got couple more here. Hey, tangent 23 degrees. Okay, so I've got to convert back to degree mode, and then tangent 23. My answer 0.4245 when I round. Hopefully you're getting the same thing. Last one, cotangent 40. Okay, I don't have a cotangent button, so I'm going to put in 1 divided by tangent 40. That means the same thing. There's my answer. Yeah, I'm in degree mode, 1.1918. Each of these, although they're these kind of strange decimals, they would be the ratios of the corresponding sides depending on which trig ratio we're looking at. We don't see the triangle, but those ratios would play out just the same. And okay, so far so good. Most of the things we're going to do with trig when it comes to finding a value, we're just going to use our calculator. But we do want to have some understanding of what these mean and where they come from, of course. Okay, so we're at about 9 minutes. I'm going to try to keep these videos somewhere between 12 and 15 minutes at the most, so that they're easier to watch one bit at a time. So let me introduce this. We'll see how far we get in the next minute or two. And we'll end up having a part 3 to this section, which will be probably pretty typical. Here's an example. Find the acute angle in degrees and in radians, and they're going to switch it up on us. Now we're told the sine of theta equals 0.5. We know what it equals. What is the angle? So it's like, it's so much easier if they tell me the angle, right? Now I got to work backwards. So it turns out each of these trig ratios has an inverse. And you may have even seen that on your calculator if you've got the similar style as the one that I'm working with here. What we need to do is to isolate the theta. Okay, how are we going to do that? Let me kind of bring this down. We're going to take the inverse sine of both sides. So the sine, and it's almost looks like it's being raised to the -1. It's not. That's just the notation. Inverse sine both sides. Why do you think we would do that? Because sine and inverse sine are going to cancel each other out. And the next thing we would write is this. Those are gone, and I've got theta equals inverse sine of 0.5. Then I'll grab my calculator, and mine, it's the same button as my sine button right there. If I hit it twice, then it'll cycle through and it'll give me that. And if I put in 0.5, I'm still in degree mode. This one turns out has a really nice answer. Inverse sine 0.5 in degrees is 30. So there's my answer in degrees, 30 degrees. Of course, they want me to do this in radians as well. So if I switch back to radians and do inverse sine of 0.5 that way, I get this answer. So, okay, rounding that, I did this ahead of time, and I just went to 3 decimal places here. 0.524 radians if I round it. Typically, we're going to have to round these sort of things. In this case, we know that 30 degrees from earlier is exactly pi over 6 radians. You could have answered that way as well. Usually, it's not going to come out so pretty. Okay, I'll tell you what. I'm going to show you guys the next one and stop the video here. So try tangent theta equals 4. Try and get the value of theta in degrees and in radians. I'll stop the video here. Good luck with that. I'll see you at the next one.